Good morning. Good morning, Freddy. Dear all students, only 12 members are present. Am I audible clearly? Please, anyone respond me out of total member? Am I audible? Or you also just join and log in? Dear all students, am I audible? Please respond me. Anyone? Hello. Okay. Okay. Thank you. B03, B34 responded. Nice. So very less students. Why students are not joining the lecture? Given offline तो नहीं आने वाला है. At least we are continuing with the online. Then also the students are not joining. It's very bad for us. How the subject you have to grasp. Okay. So anyhow, within 3 minutes, I have to start it because I given a time to 9:40. So again, 3 minutes we will wait for if anyone want to join just for a couple of minutes. Okay, fine. So dear all students, now it is 9:40. Actually today there is no COE lecture, but due to your SS Kadam madam, Sanjeevani Kadam madam is on emergency leave. So today I got first lecture. Okay. So maybe she will engage my tomorrow or next or coming onwards lecture 1 or 2. So this is your kind information. Uh, So for that reason, today first lecture I have to start with the computer organization and architecture. Okay. So dear students, as per syllabus, in the unit number 3, I am going to cover today the memory hierarchy, that is cache memory. So today I am going to cover that is cache memory. Once we covered cache, already I have to cover this much of the portion. This much of the portion I have to cover. So next coming portions for pseudo operations, for synthetic instructions and assembly language programs, accessing data in the memory addressing modes. For all these concepts, if you have to understand, then you need to study first memory hierarchy and cache memory. So before going to your next portion of third unit, up to this much, because this much I have to cover in the last two lectures. Okay. So before going to this topic, directly I will move to the memory topic. After that, I will come to remaining portion of your third unit, that is instruction set architecture and the memory. Okay. So please, you understand that if I am started this portion means I am skipped this much remaining portion. Okay. So it's not like that. For your understanding purpose, I am skipping and I have to start today with this memory hierarchy and cache memory. After that, I will come to this remaining portion of your third unit. Again, 1 or 2 units lectures we have to cover this third unit module. Is it okay for all of you? So for that, we'll go for memory hierarchy and cache memory. So as of all of you know, you have to heard something about cache memory. Many memories you have heard: dynamic memory, static memory, ROM, RAM, ROM, EEPROM, static memory, dynamic memory. Like that, there is a one cache memory. So the cache memory we have to call as temporary memory, because for the temporary storage purpose we are using a some memory. For those memories we call it as cache memory basically. Okay, so that topic today we are going to uh, listen. Okay, so for that I have to prepare the notes. So here today's concept I have to given you memory organization concept. That is memory organization concept. So in that memory organization, first thing that is we are concentrate on objectives of the memory hierarchy. As your syllabus, memory hierarchy. This is your syllabus, and cache memory. So there is a cache memory is available here. That one also. If this all the things is comes under cache memory and virtual memory. But for your syllabus, only cache memory is there. So this is your syllabus today. What we are going to cover as per your syllabus. So if time is there, then I will move to virtual memory is also. Virtual memory means some virtually basis we have to use it. Online basis we have to use it. Some memory, that one also if time is there, I will go through it. Okay. So first I will move to the objectives. Next I will come to the hierarchy, memory hierarchy and cache memory. Please remember these things. So is it fine all of you? Till only 30 students are present at the time of 9:45. Very bad it is, very bad situation. Why the students are not interested? Okay. So the main objective of the memory is how we have to explain the memory hierarchy. Memory hierarchy means what? One by one, smallest to biggest. We have to arrange it. That is nothing but memory hierarchy. And descriptions of main memory. So your computer is having a main memory. Mobile is having a main memory. CPU system is having a main memory. That one we have to describe it. After that, we will go for cache memory, and after that, we will go for virtual memory. So mainly there are four main objectives: memory hierarchy, description of main memory, descriptions of cache memory, and some definitions of virtual memories. Okay. So here at this point, the main hierarchy of the memory. So look into here. There is a one diagram is available for the standard memory hierarchy. So it is a downward direction, it is an upward direction. Either you have to move from up to down, or you have to move from down to up. So increasing the capacity and increasing the speed. So here at the first hierarchy, that is a register. Registers are nothing but what? These are the memory only. So these registers we have to use it for to store the some kind of information or some kind of data or some kind of any values. And after that, we are using a cache. This cache, we say it is a RAM memory. So if our computer is having 1 TB of hard disk or 512 MB of hard disk, it may containing 2 GB of RAM, 4 GB of RAM, 8 GB of RAMs. So to supporting the register containing the information, that one we are using the cache memory. So that cache is nothing but, for the example, RAM in the system, in the computer. After that, main memory. The main memory is nothing but your hard disk. Cache memory is nothing but your RAM in the computer. And at the last one, long-term storage disk, or we say it is a hard disk. Hard disk is also, see, hard disk is your uh, uh, that is long-term storage and main memory. Along with that, extra you are using the memory with the hard disk. That one we call it as the main memory. For example, your pen drive, your external hard disks, and cache memory is nothing but your RAM, and only the register we are using for the storage purpose. So here clearly you have to understand increasing capacity. So if bottom to top to bottom you have to move, the capacity of the execution is going to be increases. And if you move from bottom to top, because larger memory to the smaller memory, then the speed is going to be increased. Both are parallelly vice versa, but in the opposite direction. That is capacity and speed of the memory. Capacity and speed of the memory. So the main memory and the hard disks from two levels of computers, that is memory hierarchy. So for that, in the memory hierarchy, the main storage and arranged in a such a way that those are different stages of techniques, that is nothing but registers, cache memory, main memory, and long-term storage, nothing but a hard disk memory. So this is your memory hierarchy. How the memory hierarchy should be arranged? At the top, register, next cache, next main memory, after that hard disk, or we say long-term storage memories. So in this way, and one more, for the hierarchy, memory hierarchy in a computer system, how it should be available as our usually used computers, desktop computers, or it may be a laptop computers. So the hierarchy in a computer system, there should be ordinary memory we are using. The ordinary memories are nothing but magnetic tapes. So magnetic tapes are nothing but what? In the olden days, for to seeing the films and stories and all, they are using vishas, CD and vishas. So that one we have to say magnetic tapes and magnetic discs. audio and video. Okay, magnetic tapes are audio, magnetic discs are video, and those are connected with our input and output processor of the computer. So from that processor, it is going to be connected with main memory, and from the main memory to CPU, that is central processing unit, and from the main memory to cache memory. This is the entire hierarchy maintained in a computer system. So main part in the computer system is IO processor, and that IO processor nothing but input and output. So whatever we are giving an input to the processor, that processor will process it, and that output is going to be sent to the output screen. So here inputs are nothing but magnetic tapes and magnetic discs, and outputs are nothing but that main memory display and central processing unit, that is CPU. So one more is cache memory they have to use. So now one by one block, we have to observe that magnetic tapes. The magnetic tapes, it is nothing but a input device, and this magnetic tape is used for audio. So in the olden days, maybe you are not aware, in before 2000 and all, that time 1990 to 1995 majority. So we have to use them cassettes for this thing, the audios. We are using the cassettes. In that cassettes, there is a one chocolate color reel is there. From one wheel to another wheel, moving from right to left or left to right. Okay, that chocolate color reel is there. That one we are saying a magnetic tapes. That is nothing but a storage device only. So in that magnetic tapes we have the same, and magnetic discs in the next block. So these magnetic discs are used for video purpose. Same as in the audio, it's videos, and along with the TVs, there is a one set of features are there. So from the features, they have to watch the movies, films, and other good stories. But nowadays, everything is computerized. Electronics are there in the mobile. Also, you have to see without any magnetic tape assigned magnetic disc. Nowadays, this story is different. That is totally changed to cache memory and main memory. So these are the olden days used for ordinary memories. So these two inputs given to the processor, that is input and output processor, and it is processed in the main memory. From the main memory, it is sending to the CPU for the central processing purpose and memory, and it is going for the cache memory if we need the cache memory, that is extra memory. Okay, so this is the main concept of memory hierarchy in a computer system. So much explanations is there. I'll give you all these explanations. And also in the cache memory, they have to use it for perpetuation of a program that presently being executed for the CPU, and also for the temporary data that is repeatedly needed in the current operations purpose. Also, we have to use it for cache memories. Okay. So next we will come to the main memory. So in the main memory, there are mainly two types. One is static memory, and one more is dynamic memory. So in the main memory, the fundamental stage unit of a computer system, we call it as a fundamental unit of a computer system. And relatively, the large and fast memories we have to use it for to store the programs during the computer operations. So the technology is used in the memory work is based on all the semiconductors integrated circuits. What is memory? Memory is nothing but it is a semiconductor integrated circuits. So in that semiconductor integrated circuits of the memory, again there are two types, that is static memory and dynamic memory. So static memory in the sense what? Whatever the data you are stored, it may be in the form of a flip-flops, which is the information remaining to be stored in the flip-flops. So those are just statically you have to store it. Whenever you need, just retrieve from the same memory. But dynamic memory in the sense you have to dynamically access the data whatever stored in the memory. That one is dynamic memory. Okay. So this is the main memory of dynamic and hard disks. So after that, you will come to the main memory uh, and the processor. How the working is between main memory and the processor. So here there is a processor, because you know the processor, the microprocessor, many processor you learned already. 8086, 8085, 8087, 8088, 80257, 259, 255. So many processors you have to study. So all the working, the program processing is happened in the processor, and that is manipulated with the memory, main memory. It may be a dynamic memory or it may be a static memory, and these two working functionality is to be done through the cache memory. The cache memories are nothing but your RAM memories. So without RAM, your computer will not work. Your computer will not process any data. So if you have a desktop computer in your home, anyone is using, you open that PC panel, and there is a one like a scale size, small scale size. There's a one plate is there. That is, we call it as a RAM. So that RAM you have to remove from the memory. Your computer will not work it, because everything is should be happened through the RAM memory only. So the RAM memory is the intermediate device between the processor and the main memory. That is what RAM is using for that. After that, in the processor, like also some RAM kind of memories we are using. That one we call it as a L1 cache and L2 cache. Here the main memory. So that is with the L1 and L2. So how much the memory, temporary memory we have to use, that is in L2. But over than that, if we are in any extra memories, that one also we have to use it in the processor cache. L1 also we are using that data. Okay. So after that, if we are going to split, if we are going to split in the cache organization, that is split cache with the organization. So here the processor uses one cache to store and second cache to one more cache to use for storage the data. So this cache organization is typically used to support an advanced type of processor architecture, such as the pipelining and the mechanism. Even pipelining is one of the 15 15 we have to study all the pipelining techniques and used for processor to handle to the data or distinct from those used to the data. So that is, here I have to show you one strict cache organization. Cache means what? Temporary memory. So that RAM memory, we have to say cache memory. So in that, uh, whatever the cache is acting between the main memory and the processor, so that is code for cache and data for cache. So if the information, the data is there, directly you have to send to the main memory, to the main memory from the processor, then we are using for data cache, data or information. If we have to sending the information or a data over the program code, over the coding technology, then we have to say it is a code cache. Then we have to say it is a code cache. So in the cache, there are two types: code cache and data cache. Okay. So this is the main memory and the processor between the cache. That is cache memory. What we have. So in that program, the most of the loop instructions that are to be part of the loop are executed with the multiple times, and whenever the first instruction of a loop is loaded into the cache, that time it is going to be start to the process it. So in the any way of the processor does the to have the wait for the memory and to provide subsequent instructions. Many instructions are there. We will listen into the next. Okay, so this is about the cache memory and some how to do the cache operations. So the cache operations of the processor first checks the cache when it needs a word from the memory. If the word is not in the cache, and a condition is known as the miss occurs of the word, in order to ensure the time of loss during the miss concepts, the process for accessing the same word from the main memory is simultaneously activated. If the word is present in the cache, then the processor uses the cache words and then disregards the results from the main memory also. And these mechanisms we call it as hit to cache. So whenever the data is reached to the RAM memory, that is hit to cache, we have to say. And the block in that word loaded into the main memory. So the cache and the word sent to the processor, all the data depending upon their design and cache processor, the interface, the word of their loaded into the main processor from the main memory from the processor. So all these particular main operations of cache memory. So in that cache memory again, they have a quickly found for the word direct mapping, associative mapping, and set associative mapping. Different types are there again. Direct mapping. So in that direct mapping, it is a procedure used to assign a cache block in the main memory to specific line in the cache. If a line is already filled with the memory block and a new block needs to be loaded. So that is our direct mapping. So here, just I'll give you here one diagram for the direct mapping of a main memory to cache. See, a number of blocks are available here from block 0 to 1 up to block 513. Block 512, 513. Okay, 2513. And here from 1024. So totally n number of memory blocks are there. N number of memory blocks are there. As per user requirement, you have to cut into the memory size and store the data. So here it is a cache memory. In the cache memory, there is a tag 0 to tag n number 5111. Okay. So total the line number is 511. So line number 0, line number 1, line number 2, line number 3 up to 511. So that is tag 0, tag 1, tag 2, tag 3 up to tag 511. So here also the block for the tag same with the number, how many input lines are there in the cache memory. So what it will do, based on the requesting, the cache memory will act as per the user request. So at the first line, the first request at the tag 0, the block for tag 0 is working with the block 0 to block 1536. Block 0 to others, we have to say block 0 to block 512 because our maximum capacity is 511. So that is top minus 1. 511, it means that 512 minus 1 is nothing but 511. So these two lines are blocked for 0. Like that, different blocks they have to create it in the memory. For example, if at a time you are using a one word file, one document file, one PDF file, one JPEG file, right? Like one ping file, different categories of files you have to open at a time. So for each file, Word file, doc file, PDF file, like that, each file, one blocks it is creates in the cache memory, and according to that, it will act whichever you need. That is, it will going to be fetch and displays on the output. Is it okay? So that is the main function of cache memory. So up to that, here in the bits wise also they have to manipulate in the direct memory partitionary of the memory address with the 1 byte, 2 byte, n byte up to w bytes. W is nothing but word. That is, at the beginningly you have to use tag, say 10 bytes and 1 bytes, that the bit identifies in a row cache. So but at the beginning is tag byte. Up to that, 1 bytes, 2 bytes, 3 bytes. It is started and ends with word byte. Word is too much long. Double word is also there. Word are double words you have to use. That is the bit identifying word offset into the block. So this is for your direct mapping. Next one is for your associate mapping. In the associate mapping, only tags and word bits are using. You didn't use intermediate bits. So intermediate bits are, it may be any number. It may be any number. So directly you are using tag bits to the word bits. Bits identifying with this. So because it is associative means inside that all the bits are available. Any required bits based on the user request, they have to select the time, fetch the data, and it may be a Word file, or it may be a document file, or it may be a PDF file, or it may be a JPEG file, whatever it may be, the different files they have to display on the monitor screen. So last one, third one, that is set associative mapping. It is almost same as associative mapping only, but the user can set to different files. User can create the different files in the memory. For example, if you are creating a student data, one side, department data, another file, and your study data, third file. So different files you have to create it. That we say it is a set associative map. That we say it is a set associative mapping. So tags we have to create it 1 to 511 n number of tags, and cache memories from the tag 0 to 511. And here also you have to use it as set 0. So these tags are used for some particular purpose, some particular or some different kind of files purpose. That is set 0, set 1, set 2. This is set 2, set 3, set 4, up to set n number of sets you have to create it, but that is all including set tags are less than 511. That one you have to keep in your mind. Okay, so this is all about your cache memory. That is with the different blocks what you assigning as per syllabus. See, as per syllabus, this is the to syllabus memory here in that cache memory. Whatever we have to explained up to now. So again, some examples and all it is giving, but you don't go through that. I will give you the clear notes. Okay, I'll give you clear handwritten notes on this third unit. So again, this third unit, two lectures I need. So tomorrow I got one lecture at the morning same time, and next I got the lecture on Thursday and Friday. So tomorrow means where Tuesday and Thursday I have to complete this much portion. I have to complete this much portion of your third unit, and after that I will go for one test. Maybe now only I will announce to you all of you. Maybe this coming Friday you may have a test on model number 1 and model number 2. So parallelly, you are continuing with your study. Okay, don't make any delay. You may have test on Friday, coming Friday, first hour. So before that, I have to complete this your third unit. These all of you have to cooperate. But I'm very bad, getting bad because only less than 50 students are present. So what about remaining 110 students, more than 110 students are absent. It's very bad for the class. So if we are explaining an important concept, if students are absent, then how they have to get it? So for that, what we will do, I have to complete this cache memory and this memory concept by the today's lecture. And tomorrow's lecture, pseudo examples and synthetic instructions with the assembly language programs I have to cover. And in the Thursday, I have to cover this accessing data in the memory addressing modes. Only two more lectures I have to need to complete your third module. and immediately completion of your third unit, I have to give you handwritten notes. So dear all students, all of you getting right. The first unit, my handwritten notes, and second unit, handwritten notes. Everyone is getting right. Please respond me. Students, please respond me. Are you mentally present or not? Okay, just a minute. I'll take attendance of all. Today is 25 for 2022. So please uh, don't log out. I'll take attendance. Yogi Raj Deshpande. Please, what is your rule number? Why you not mentioned with your name? Yogi Raj Deshpande. Tell me your rule number, otherwise I have to put it absent.
B41, sir.
Yes?
B41.
B41. So why you not mentioned with your rule number? Only your name is available here. You have to change it, okay? Today only you have to change it because other stops also they make it as option if there is no rule numbers.
Okay,
So
sir.
this is the concept today's. Uh, okay, due to less students, I have to stop it here. And please, all of you go through this third unit. Okay, 192 unit. Unit number 1 and unit number 1 and unit number you have to do study for your first class test. It may be happen on Friday. Today only I have to announce it you, and up to Friday I have to complete your entire third units. Okay, so this is my side. So anything else, let me know please. So anyhow, we have to complete the NAC visit, NAC committee review visit to our college, and now onwards we are free and free to conduct lectures. So every day we have to day by day conduct the lectures without any loss of classes or lecture, and we have to cover all 100% syllabus. So only after that, only one unit is unit number 7 is 8 hours. Remaining all units are 4 and 5 hours. So easily we have to cover your syllabus also, not a matter. Okay, dear students, is it fine? Or anything else, please you have to ask me. Want to ask anything? Any doubts? Any difficulties? Third units, I'll give you the notes. After that, you will get it easy for this notes, this unit also. So please, all of you go through this unit number 1 and unit number 2. Already I have to provide it, those unit numbers, 2 units notes also, just you go through it. Okay. So that's all about my side. If anything is there, you have to ask me. Otherwise, you have to wait for next lecture. Okay. If no any questions, please you can leave the meeting and wait for next lecture.